Hello everyone, welcome back. So today what we'll be trying to do is to reproduce this sketch, which you're currently seeing working, which is the Metaball algorithm. So I won't go on the whiteboard just because we're pretty much only going to use I can go on the whiteboard to explain just the balls that we're using, but to explain the Metaball algorithm, it's basically summing up um, the result of this expression right here. So we'll just be using the expression right away. I'm not sure I understand 100% of it, but it doesn't matter. They provide me with with the formula. I can just use it, right? So what I would recommend you is to read a little bit about it on the Wikipedia page. I've done my reading. It's pretty much using the inverse square root. Well, basically, the distance kind of this would be over here is kind of the distance, the distance between like a given x and the ball x and a given y and the ball y, and then putting that over one, which is the inverse of it. But we won't be using one. We'll be using the radius of our balls for that. But let me just go and explain quickly how the balls are moving around and bouncing on the edges, just so that we got that understood. So let me go over here. Let me erase what we have from the previous one. So there you go. God, it's powerful, this thing. At least it cleans it pretty well. Great. So hopefully it's dry enough. Yeah, it'll be fine. So we'll be creating a class ball. This class will have a position, which will be a vector containing x, y, its position on the screen, on the canvas, sorry. And it will also contain a velocity vector. We could technically have like Vx for velocity x and Vy for velocity y, since we're only like changing those like x and y velocity separately and not like together, so it wouldn't matter. But let's just use velocity as also a vector xy. This vector will affect basically position. So what we'll have is some kind of update function, which won't receive any argument. We don't need to update the velocity based on the acceleration. There won't be any acceleration. It'll be just a constant velocity that we're adding to the position. So here we can just do like position dot add using the p5 vectors, but dot add the velocity, right? So this is just doing like pos dot x plus equals vel dot x, right? This is and same thing for the y. It's pretty much that, but concise. Put it concise in the function, so it's great for us to use. The other thing we'll be doing is also bouncing the balls from the edge of the screen, basically. So also the ball will have some type of radius. It'll be some type of number, let's say 15, just for explaining it. So radius will be the point from the middle of the ball to the edge, to any of the edge. So we'll have in the update function. I don't see the need of doing a separate function for the edges. You might want to, depending on your use case and like especially what you want to do after in the position. Maybe you want to update different stuff, not specifically just like maybe you want it to wrap around instead. Like I don't know. I'm personally going to put it in the update function. So we're going to say like if the pos dot x is smaller than 0, but think about it, pos dot x is the center of the circle of the ball, right? So I don't want to, and let's say this is the edge of the canvas, right? I don't want to bounce it whenever the center of the ball is hitting the edge. I want to bounce it whenever this part is touching the edge, right? So what we'll do is instead of 0, we'll say less than the radius. radius, or I'll just write or. It might be easier to understand. Or let me make sure you can see that. Yeah, I think you can. Great. Or whenever the pos dot x is greater than the other side of the canvas, we'll do the same kind of thing, but this time it won't be 0 or the radius itself. It'll be greater than the width of the canvas minus the radius, right? So the width minus the radius, right? So whenever the center of the ball, it's this, right? So the width, I'll just write W for right now, just so it does fit on this. The width of the canvas minus the radius. So whenever that condition is true, then we want to bounce based on the x, right? Change the velocity for the x velocity, right? So the speed at which it's moving on the x-axis, we want to reverse it so it goes in the other direction, right? So what we can do is just do val.x times equals velocity times something, times equal -1. So reversing, getting the inverse of the current velocity. And we'll have the same condition for the y, another if, but it'll be position of y, radius still, or position of y greater than the height, not the width, but the height minus the radius. So that's going to be the update function. We'll have a show function. Pretty much self-explanatory. We're just going to draw, or we're going to call the circle function from P5 with the position and the diameter, the width and height of the circle. Just the diameter of the circle. So the radius times 2. So that's pretty much the ball. And then afterwards, what we want to do, we'll also be creating, on the canvas, we'll be creating a grid. So this grid will be used for rendering Metaballs algorithm. Because, let me just make sure this microphone, yep, that's good. So because we could use, technically, the best way would be like to use the pixels of the canvas, but that will be demanding on the computer, on the resources that it's taking. So we'll map the algorithm to a grid. But that's pretty much it. So eventually in the sketch, we'll need to go to do 2 for loops over all the columns and rows of that grid. So let's get started writing this. Over here, there we go. So let me remove everything. I don't even need this. Okay, there we go. Let me just keep the canvas. Let me keep the draw loop as well this time, because we'll be using the draw loop. I want to see something change. We'll be removing everything and we'll be redoing it all together. And I would suggest to you to create a ball.js file, or you can put it still in the sketch.js file, but technically it'll be, you'll also need to link it in the HTML file. Give me a second, I'll be ready. All right, great, so we're back. So we're pretty much starting fresh. So just regular setup function. This, don't need to care about this. We just have create canvas. I'm making the canvas as big as the current screen size of the window. Frame rate 30, you don't need this. I'm just using it for my purpose, but it doesn't matter. So as long as you have create canvas of some given size. So what I'll be creating first is just getting the amount of columns and rows that we're going to use for the grid. And this is going to need some type of how much space does one cell on the grid take, right? So what's the width and height of that cell, right? So we'll call that the scale of the grid. For right now, let's just do something big, like 30. And here in this, after creating the canvas in the setup, we have access to width and height variables. So we can say cols equal the width divided by the scale, right? And same thing for the rows, but I'll need those variables created. So let cols and rows. These will just contain the amount of cols and the amount of rows that we can use for canvas. There we go. So now I'll want to create like an array of balls. Let's just create one ball for right now. Ball, there we go. And right now we need to define this class that we talked about on the whiteboard. So like I said, I've created the ball.js file, linked it in my HTML file, and then you should be able to have to write anything in here, and it should be available in the sketch.js file. So we'll create a class called ball. You could call it circle. It doesn't really matter. In this case, we're just doing a sketch for ourselves. If you were in a big code base, I would suggest making your naming really good, just so that everybody understand what you meant by this. Because if you write it, you know what you want to do, but not everybody knows what you're going to do with this code in the future, right? So we'll have a constructor. There we go. And like we said, we'll pass the position, the velocity, and the radius to this. So here we'll have this dot pos equal the pos that was passed, this dot vel equal the velocity, and this dot radius equals the radius, right? One thing as well I want to create is this dot diameter, just because technically we could just calculate the diameter whenever we need it, but since we're going to like use this ball every time in draw, I'd rather just calculate it prior to it being used and then just use diameter, just so we don't need to calculate it every time through draw. Great, so now we'll have our update function that we said we wanted to have. And the first thing we can do is just update the position based on the velocity, like we said. And we'll do the two if statement that we need. So if the position.x is smaller, and like we said, this dot radius. Otherwise, it'll be whenever the middle of the ball is touching the edge, and not the edge of the ball, actually. So we'll want to use the radius, or whenever the other way around, whenever the ball is bouncing on the other side of the canvas, right? So this dot pos dot x is greater than the width of the canvas minus the radius. Great. So whenever that is happening, we want to invert the velocity, right? So that it goes, let's say the speed is 1 for the x-axis, and now it's -1 whenever we hit a wall, right? It bounces right back in the other direction. So we'll do this dot velocity dot x times equal -1, right? And we'll copy this if statement, put it here, and we'll do the same for the y. So it'll be the same for the first condition, and then here it'll just be height that changes, otherwise it'll be the same. Okay, and then we just need to update the velocity, the y velocity. Great. And we'll do a show function where you could call it draw, I think, but I just don't want to confuse the draw method from P5 and some other method I want to create to display stuff on the canvas, so I'll call it show. But you can call it pretty much what you want. It shouldn't matter, I believe. Let me know if I'm wrong on this, but I'm pretty sure it shouldn't matter. So here we'll be just drawing a circle at some x and y of the ball, passing it the diameter. So the circle function expects the diameter, and the ellipse function expects the width, the diameter on the horizontal axis and diameter of vertically. So in our case, we just need a diameter. So this dot diameter. There we go. Great. So we're pretty much done with our ball function, or ball class. Sorry. Now, if we get back to this, we want to create a new ball. So we'll say ball equal ball equals new ball, passing it a position. Right now, we'll just do random position on the canvas that is between the range of the ball radius, right? So we'll kind of remove the radius of the ball on the left side and remove same thing here, bottom as well, top as well. So let's just do it. So create vector, right? Because we need a vector because we're using add in the update and whatnot. So create vector random x, which is going to be between, and we'll need a radius. So let me just create a variable for the radius, const radius, equals, let's say, random between, let's say, 30 and 50, pretty small balls, it's fine. So we'll have between radius and width minus the radius, a bit really similar to what we did on the update function for the bouncing on the walls, and random between, again, the radius and this time the height minus the radius. Great. So we're done with the position. Now the velocity, what I want to do is get some random velocity. So what we can use is p5.random dot vector dot random 2D, which will give us a random 2D vector, so xy random between -1 and 1 for both of them. And then we can set the speed of that by setting the magnitude, right? The length of that vector, kind of. In our case, it's going to be the velocity, so it's going to be eventually the speed of that direction we're going in. But think of it as the length of the line of the vector, kind of, if you want. So we'll be setting it to, I don't know, random between, let's say, not too small, so maybe like 1.5 and let's say like 5, right? I don't want it to go really, really small. Slow. And the last thing is the radius, which we already have as a variable. There we go. So we've created our ball. Now we can try to display the ball, to show the ball. So in the draw function, let's make sure the fill is 255 so we can see it. And let's also remove the stroke, just because I don't think I'll want the stroke. There we go. Okay, and let's do ball.show. There we go. Oh, ball.show. Oh, there we go. So every time I refresh, every time I save, it refreshes, it should give us a random positioned ball with a random radius. And right now it's not moving just because we didn't call the update function on our ball. So ball.update, there you go. Now it starts to move in a random direction with a random speed, right? There we go. Maybe the speed is not enough, right? Between 1.5 and 5, it's not enough. Let's say between 3 and 5. That's a bit faster. That's fine by me. Okay. So now let's just try to make a lot more balls, right? Let's say 10, right? So we'll have let or const balls equals an array this time, and we can have some amount here, right? Amount be equal to 10, let's say, and we'll use that value to know how many balls we're going to draw. So here we're basically put all of the following lines into a for loop. So for let I is equal to 0, I is less than config.amount, I plus plus, there we go. Let's put all of this into there. Okay, great. Let me just make, there we go. Now instead of setting ball equal to this, we'll do balls push that ball, that new ball. Great. There we go. Now in here, it's giving us an error because it doesn't, like, ball is not defined. So what we'll do is we'll do for loop, for of each, for off loop, sorry. So for ball in or off the ball array, the balls array, sorry, there you go. So now we've defined the variable ball as being one element of the array balls, right? There you go. So now every ball is being drawn and every ball is being updated. So that's great. So we have our balls that we want to use for the algorithm. So now let's make the algorithm happen, right? So the algorithm, if we take a look at it, what we need is basically this over here. Let me try to zoom in a little bit. There we go. So this is exactly what we need. Maybe I can put it here and zoom in. That might be better. Okay, sure. There you go. That's fine. Oh no, it's not fine because my head is on the top of it. But okay, there we go. So we won't be worrying about this part over here, which is over there, which is the z-axis. We're not in 3D space, so let's not worry about it. The first thing we need to do is we know we need to do a for loop for all of the columns and the rows. So we'll do for let col equals 0, first column. Col is less than the total number of columns we want. Col plus plus, there we go. Then what we'll do is we'll do another for loop for let row equals 0. Row is less than the amount of rows that we have. Row plus plus, there we go. There we go. Now inside of here, this is where the magic happens, right? So we'll need some kind of summation that happens while we execute this on all of the balls. We'll need to know the current x and y. So right, so if you take a look here at this formula, right, there's x minus x0. If you take a look at just under it, where x0, y0 is the center of the metaball, right? So for each of our balls, we'll use the x and sorry. We'll use the x and y of the position of the ball as the x0 in the formula and y0 in the formula, right? Oh, never mind, sorry. Got something in my throat. Anyway, and the x that is over here that we're subtracting from, and the y, same thing, is going to be the current position on the canvas we're going through, right? So what we need is an x and a y, right? Those values, we can just use the col time the scaling. And same thing for the y, though it's going to be the rows. The current row, sorry. Row. There you go. Awesome. So now the sum, it's basically, we're going to use the sum. Well, let me just do it for one of them, right? So let me do let or const value is equal to the first balls index 0, and then we need to execute the formula, right? So we'll have the sure. Let me just think about it. Okay, yeah. So we'll do square root sqrt, which is the square root that we have in the formula, and we'll need to do first thing first is power the power of 2, but power of x minus balls index 0 dot position dot x, and we want this to the power of 2. Great. Now we need to add to this the same thing but for the y. There we go. We'll do y. Great. And now we need to divide this, and like I said at the beginning, we'll be using just because one will be, the value will be too small for us to use. So we'll be dividing by, and also using the radius for the division will make it so that whenever you, it will be based on what will be rendered for the Metaball algorithm will be based on the size of those circles. So it's going to be more representative of our circles that we have, of our balls. So we'll use balls index 0 dot radius. Great. So now that value, we can say maybe stroke, and we can assign maybe the alpha value. So let's say it's white, and we set the alpha value to, let's say, value times to 200, right? Let's see. And because value is going to be a pretty small number, and we need a value between 0 and 255, and 255 is like 100% opacity, so it's like there, and 0 is just transparent. And we'll do a rectangle at the x and y with a size of scale, right? Whoa. There we go. Let me close this. Great. So if I were to do this right now, there is definitely a problem. So let me see. A is not defined. I've put a typo over there. There you go. Okay, what else? React. Yeah, it's rect. Okay, so everything seems white, probably because this multiplicator is way too big. Again. Whoa, no. Oh, wait. Hi. What's happening here? Oh, I don't want the stroke, I want the fill value. There you go. Okay, and I'll put back the multiplicator, so times 200. There we go. But now you can see it working. It's the actual algorithm that is used for the Metable algorithm. The only thing is that right now it's basically only uh, only interpreting one ball, right? Like we defined it. So we need the summation of that for all of the ball, right? So that's why I was going for the sum, right? So let's do that. It won't be long or difficult to convert. So we'll just do another for loop, the exact same as this one. We'll go through all of the balls. There we go. And we will just add to the sum. So we'll do sum plus equal this. And instead of balls index 0, we'll just do ball. Right, there we go. And we just need the closing curly brace. There we go. And now instead of value, we'll use sum. There we go. Now it's really bright because this may be a bit too much of a value. Maybe if I were to do 100, right? Or maybe not enough, 100, 150. Okay, that looks better. Let's maybe not stop showing the balls, right? We could have like a if config dot show balls is true, then we show the balls, so we'll need that configuration. So we'll go put it here and we'll put it false for right now. And there you go. We pretty much have the algorithm done. What we can do maybe to get a better resolution, we can reduce the scale to maybe 20, right? So removing 10 a bit, and even maybe 10, right? But the smaller you make it, the closer to pixel, like the closer to the amount of pixel you have in the canvas that it's going to use, which will be really demanding on the processing side of things for the computer, right? So I would say 10 is a good number. You have good details, but still not like you see here. Even my computer is telling me that it's taking more time than 50 milliseconds per iteration through draw. So maybe 10 is not really a good amount, maybe 15, right? And this is because we're looping over this, right? Which makes sense. Great. Let me just think. Right. So one thing you could do also is to take that value and maybe instead of doing it white, you could do something like color mode equal HSB. I think no, not HSB. Oh no, well, not color moods. Okay, HSB, yeah, HSB, and we can put it back to so HSB U. It doesn't matter. Saturation, let's do 0. Luminance, let's do 100. Okay. And then over here, the fill, we can do the sum times this. Saturation, brightness, saturation, we can say 200. And brightness, we could say 50, right? Or 100. There we go. So there you have the Metable, like more known Metable representation. And we can still show the balls, right? Though I'm going to move this, not duplicated, but move it after we've drawn, so we can draw the circle on top of it. Let me move this as well over here, and let me move the no stroke, since we're not using stroke at all. Let me move the no stroke over in the setup. There we go. And now if I wanted, I could show the balls. So let's do show true, sorry. There we go. So now we have the balls on top of the metaballs, if you so wanted to see them. But let's put it at false again. So now we really have the algorithm. What we could do now, so we're done. Metaball algorithm, there you go, it is done. What time are we at? Okay, 30 minutes. I'm going to add on to this, but please stop if you want to try it on your own. But what we're going to do is it's going to take a bit of time. I don't even know, I haven't tried it. I've done it before, but it's been a while. But what we're going to do now is use what we've done in the previous video, which was the marching square algorithm, and try to introduce this into the Metaball sketch, right? So yeah, that's pretty much what we're going to do. So I'll let you right now to stop the video if you want to try it on your own. Try to make it. Just look at the previous video or just take the code from the previous video and try to make it work with this sketch. I'm not sure on the performance based on how I've done it in the previous video, but we'll see what we get. Possibly it's really going to be bad in terms of performance because I really haven't thought of performance in the last sketch since I was just doing static rendering. We'll see. So I'll be using, yeah, it's definitely not optimized. Anyway, I'll be copying this square over here, creating a new file for square.js, adding this over there. So please look at the previous video for understanding how all of this is done. So now what I'll do is I'll go over sketch and I'll take a look. I don't really remember everything. Okay, there you go. That's exactly what I want. So do I actually need, yeah. Oh, well, the value, we should already have the value, right? So I'm just going to take this, move this into here, and we'll have a, yeah, I know. We'll have a grid variable over here, const grid, which is going to be equal to an empty array. I'm going to fill this array with arrays. That's all I'm going to do. So we're going to say grid. We're going to say for let call equals 0, call is less than the calls, call plus plus. I'm just going to do it for the calls. So grid index call equals an array. That's all I'm going to do for the setup of the grid originally. Okay, and now what I'll do, or in the other one I called it values. I think I can still call it values. I'm fine with that. Okay, great. So now what I need to do is over here, right? I will do, let me just think about this. Okay, so what I need is over here. I need to add into values at index call index row. I need to add, I need to set it equal to an array of two values, right? The first value should be the 1 or 0, if I remember properly. Yep. Yes, 1 or 0, and the other value should be just the value at that specific location. So let me go here. So the first value, what we can say is basically the sum value, right? Sum value we do times 150. So maybe it's like 1 up to 1.5. So we can say maybe this this is less than, if this is greater than let's say greater than 1, then we say 1, else we say 0. And now what we can do for the second value is just put the sum there. And the sum, yeah, that should be fine, right? I think. Okay, anyway, now here I don't really need the grid. I don't know why I used grid earlier. Whatever, it's fine. Here I didn't call them row and col, that's fine. It doesn't really matter. Here I'll call this const square. I'll do underscore square just because square is already like a JavaScript function, so a P5 function, sorry. And I'll do square.calculate and square.show over here. And okay, so what's the error now? Square is not defined because I haven't added it here, right? So I'll need to link square, the square file we created. There we go. It is running smoother than I expected it to. Okay, never mind. Well, it's fine. So let's take a look at the show. It's just drawing lines. So actually, we do need the stroke. So the no stroke I've put earlier, I'll definitely be needing it. I'll do no stroke just after because I'm just going to. Oh, and is it still in there? Yep. Okay, that's fine. So we'll do here. We'll do stroke. Oh, and it's in HSB. So I guess this doesn't matter. This doesn't matter. This 100. There we go. Okay. So stuff are breaking, definitely. So what is the issue now? Okay, let me think. Oh, we don't have a threshold. Oh, yeah, that makes sense. Well, it doesn't make sense. The fact that we don't have it is an issue. So threshold, and we'll say 1. Sure, why not? So now threshold, oh yeah, it's already working. We can see it. Let me go here and let me say over here, let me put sum is greater than config.threshold. There we go. Okay, it didn't change anything, which is as expected. Let's put also the stroke weight, and we'll put it in the setup function just because we don't need to call it every time. It won't change. I'm just going to have to leave it as the same. So stroke weight over here. Let's do 3 just so it's a bit more visible. There you go. So now we've done both of them. We've done it, the metaballs and the raycasting. The marching squares. I was having a little blank here. You see, it's definitely not optimized because it freezes from time to time. If I move my camera, give me 1 second. There you go. I can move it. So here you can see it says, well, if I open it, it says like, oh, it took more than some amount of milliseconds, right? If I zoom in a little bit, there you go. So definitely not optimized, definitely could be better written. Possibly if I remove this, it would run faster, I'm not sure, but maybe. There we go, so now it's blue. Not sure, maybe this needs to be 255 for it to be white. No, well, it doesn't, I don't know. Anyway, 255 seems better though. It's still taking like more time, definitely because of my squares. They are the worst thing I've ever written, but it works. One thing we could do, maybe it's not because all of this, maybe it's because the scale is a bit big, right? A bit small. Maybe 20, it won't, like it'll be on the edge, but it'll be fine, right? It always depends also on the computer you have. Maybe the computer you have is like a beast and it runs like smooth. Mine, well, you can see it. So it's kind of a lava lamp or something else. It looks pretty good to me. Hopefully you've liked the sketch and you tried to do something different. Maybe you make a more efficient code than mine. Hopefully you do, because mine is definitely bad. It works, but it's definitely not great. But yeah, thanks for watching. Let me know down in the comments below what you do with this, what creative way you use to make this look better than mine. Mine is really not the most beautiful as
That's what I would say. But yeah, so thanks for watching. Let me know down in the comments below what you want to see next. And leave a like if you like the video. Thank you. See you in the next video.